Most of the times in relational databases, we store data in multiple tables, and therefore we use queries to combine and pull data from multiple tables. The queries that retrieve data from multiple tables are known as join queries. There are several reasons for storing data in multiple tables. The first reason is that the data typically comes from multiple sources. For example, in a university, students' personal data usually comes from the university offices, while the grades are typically reported by the instructors. Another important reason for storing data in multiple tables is the database design constraints. Relational databases are based on the relational data model. In the relational data model, the two main elements are relations and relationships. Relations, also referred to as the tables, provide a structure for storing data. Relationships, however, make links between the tables. For example, in the two student and grade tables that we have used so far in our examples, you can see that the student table or relation has a student ID, first name and last name and email columns. In this table, student ID serves as a primary key which can be used for uniquely identifying every row of data in this table. In the table grade, we store student ID, activity, and grade. Student ID in the grade table serves as a foreign key. Foreign key is a column whose values are used for relating data in one table to another table. The student ID column in the grade table serves as a reference to the student ID in the student table, meaning that if we look up a grade in the grade table, we can use the student ID to find the student information such as last name, first name, and email in the student table. The primary key in the grade table is the combination of the student ID and activity columns. This means that we need two pieces of identifying information, which are the student ID and the activity, to uniquely identify every grade in the grade table. There are three main types of joins: inner join, outer join, and cross join. Inner join, which is the most common type of join, displays the rows from the two tables that match the join criteria. The outer join, however, is different from the inner join in the sense that it not only retrieves or matches the rows in the two tables that match or satisfy the join criteria, but also returns the other rows or records that do not satisfy the join criteria from one or both tables. Cross join is totally different from inner join and outer join. It returns the Cartesian product of the records from the two tables. Cartesian product means all possible combinations of records in table A and records in the table B. Here you can see how we can use inner join in a select query. After the select clause, we can list the column names from all the tables we want to retrieve the data from. After the from clause, we can reference our first table followed by the inner join keyword followed by the next table name. This means that we can join any number of tables. After listing all the tables we are retrieving the data from, we need to specify the condition we want to use to perform the join. The condition comes after the on clause. Conditions used for the join are very similar to the conditions we can use after the where clause. We usually use equality operator or an equality condition for inner joins. In our first example, we want to generate a grade report for all the students in the student table. The grade report not only includes the grade and activity and student ID, which are all the columns in the table grade, but also includes a student's personal information such as first name and last name. Therefore, part of the data comes from the grade table and another part comes from the student table. This means that for every grade that we list from the grade table, we also need to find the first name and last name that corresponds to the student ID in the grade table. To write this query, after the select clause, we can list the student ID, first name, and last name columns from the student table and the activity and grade columns from the grade table. After listing all the columns we want to include in our result set, we can reference the tables we are retrieving the data from. In this example, we are using student, InnerJoin, grade. Finally, we need to specify the join condition after the on clause. The join condition is the condition that is used to match the records from the two tables. In this example, we use a student ID to match the records from the two tables. This means that for every grade from the grade table, we are looking for a student that has the same student ID as the record in the grade table. That's how we write this condition after the on clause. Now going to our database, you can see that by running this query, we have a big table. We will get a big table that includes a student ID, first name, and last name, along with the activity and the grade columns. Activity and grade columns are coming from the grade table, while last name, first name, and student ID come from the student table. It is important to note that in join queries, it's always a good idea to reference both the table and the column names after the select statement. For example, student.studentID, student.firstname, student.lastname, grade.activity, and grade.grade. This will help you keep track of the tables you are using in your query, so that when you are writing the inner join, the from clause, you know that which tables need to be referenced. This is not a requirement most of the times, however. You can see that in our second query, which is basically the same as the first query and returns the same exact results, I only used first name, last name, activity, and grade without referencing the table name. However, for the student ID column, I referenced the table name as well. This is because the student ID is a column that exists in both tables grade and student, which I'm referencing after the from clause. The other columns like first name and last name only exist in one of these two tables, so I do not really need to reference the table name. However, for the student ID column, remove the student table name, the query will not run. You can see that the database complains that the student ID column is ambiguous. This is due to the fact that the student ID column exists in both grade and student tables. Finally, in the last query, I just switched the two tables after the from clause. So instead of from student inner join grade, I wrote from grade inner join student. You can see that this query returns the same exact results as the two previous queries. When we are using inner join, it doesn't really matter how or which table we reference first and which table we reference second and third and so on. In left or right join queries, which are both types of the outer join queries, the order by which we reference the tables after the from clause matter.